friends, welcome to my YouTube channel AI Hack by AK. So friends, in the last tutorial I have explained you about this image uh, and the concepts how the stacking happens. In this second part of uh, the series, I am going to tell you how this is implemented uh, through the Vecstack package and how actually through code we can understand how the stacking happens. So basically, uh, you can install this package, Vecstack. So I've already installed it, and now we are importing some of the libraries here, so we can train test is some of the packages here. So from Xkillen, we imported train test split. We are importing accuracy score, KNN neighbors classifier, decision tree classifier, XGB classifier, and also Vecstack. We are importing the stacking and also naive base multinomial naive base classifier. So I have imported all these libraries, and then we are importing a data set to see uh, how the stacking works. So I am importing here the wine data. So it got imported. So you can see the classes here. So there are basically, I think there are basically three classes here. And now this is our train set. And now I am splitting my train and splitting the data into my train and test set. Now we can start with the first level model. So the what I have told you in my previous video is that the first level model can be any number of models, like 2, 3, 4, whatever you want, you can have it first level model. So I have selected here KNN uh, neighbors classifier, multinomial naive Bayes classifier, and decision tree classifier. So I have put these models in the list. I have not trained it, these model. Ideally, you should before doing a stacking, you should train all these models on your train and test set and then use it for the stacking. So I'm not trained it for demonstration purpose. Writing, I'm just putting it into a list. So most of the values will be the default values. So I have given it in a list, and then now I will do the stacking of these model. So I am giving here models. So these three models I am giving here, on which we have to create a first level model. Apart from that, I'm giving X train and Y train and X test. So what we need to do here is that what it is doing is that it will basically a number of folds is 4, and um, we don't need probabilities, so it is giving false. We are just taking uh, the classes where it is classes that are coming out of the prediction metric score is and number of folds we are giving 4 here, and we are going to shuffle it. So what is going to happen here, and what will happen here? So since we are giving it 4 here, it will divide our X train data into 4 parts and our Y train data into 4 parts. It will keep it will keep one as a holdout set, and it will predict on the it will train on the rest of the data, and it will predict on your holdout set, right? And in the at the same time it will give you the prediction, and the same time it will give you prediction for the X test, right? So it is going to generate two S train and S test. So as I told you earlier here, if you can see here, so here it is a three folds, okay? Here it is three folds. So each time the it is get train it would get the model gets trained on the two folds and prediction on the remaining fold. So it will do this iteration three time, and it will generate this prediction for the test set. So it will be done since I am giving it four models here. So it will generate four different training uh, training predictions and four different test predictions. Okay. Now if I run it here, so let's see. So as you can see here, the model one has run. Okay. So it's giving the prediction for the four folds. Okay, model second model has run. It is giving predictions for the all the four folds. The third model has run again. It is giving prediction for the all the four folds. And let's see what is the first. We'll see S train. So F train, you can see there are three models. Okay, so three models. So it is giving three train three train um, data set for us, right? So there, sorry, not data set, but like three columns of information it is giving. So this so this first so um, um, the first column that you can see here, it is basically for the first model, KNN neighbors classifier. Second one will be for multinomial naive Bayes classifier, and the third one will be for decision tree classifier. If you see that as test, it is again the three the the three rows you can say, sorry, the three columns of prediction you can say. So it's again, since it's a three model, so three times the prediction has happened, and it has generated the the uh, three columns of data for us. So now we have done our the first level of modeling here. So it's completed the first level of model. We have got our S train, which is this one, and we have got our S test, which is this one. So here in this figure, you can see um, only one, the only one um, only one train set as an output for the first level, because it this demonstration has been done for only one model. If it has been two model, there will be two, and in our case, in my case, it is three models. So there will be a three prediction for the train set, and three predictions for the test set. Now we'll go for the second level. So before that, let's see, like, what are the various parameters. I have already told you, and fold number of folds you want, then whether you want a probability or not. Then if a regression, I've kept it false because it is a classification problem. Okay, now the second level of prediction, we are using S test and S train, and then we will again train it on the data set, and then we'll do the prediction on the S test. So as you can see here, I've taken XGB classifier here, and I'm fitting the model on using the S train on the Y train. why train our actuals that we have for the training set. And S train is basically the predictions that we have got using the first level of modeling. So we have fitted the model, and now we are using this model, second level model, we are trying to predict what will be the prediction for the S test. S test again are the predictions coming from the first level from individual models, but we are we are uh, saying that uh, using um, using the predictions for the base level model, the first level model, predict what will be the output with the second level model. Yeah, yeah. So I will run this. So it is run. It is done. So its a prediction will be 94. Yeah. So accuracy is around 94% here. As you can see here, this KNN neighbors classifier is giving about around approximately around 65% accuracy. Naive base was around 83% accuracy, but it has very high variance. If you can see, the fold 0 has around 77%, but fold 3 97%. So it's very variations are very high here. Decision tree classifier, again, it's kind of okay. Um, 91% accuracy, 85, and then again 97%. So that's fine around. That's fine. But here, if you can see here, when you stack it with the XGB classifier, it is giving us the 94% accuracy. But if you go ahead and you train this XGB classifier, sorry, if you tune it again, the accuracy might go up. The same is the case with these individual models. So these individual models, before the stacking, you need to train it uh, properly, tune it, and then use it for stacking. So that will give you very high accuracy and low variance. So I think you have understood what I'm trying to say with this code, and I will mention the link of Vecstack library. You can go there and you can read it. I think it's a very nice library written by Igor, and full credit goes to him for developing this library. And thank you, and please do subscribe my channel, and if you have liked this video, please uh, hit like button, share it with your friends. And if you have found that you have not understood this concept, and very maybe I have not explained it properly, please mention it in a comment. I will get back, or I will make another video to explain this concept differently to you. Thank you all, and have a good day. Stay safe. Stay safe. Yeah. Thank you. Thank you so much.